66 million years ago, Earth was thriving. The climate was stable, the ecosystems were lush, and the planet was entirely dominated by the dinosaurs. But racing toward this balanced ecosystem at tens of thousands of miles an hour was a piece of rock measuring roughly 10 to 15 kilometers across. Looking at the projected trajectory, that rock was locked on a direct collision course with what we now know as the Yucatan Peninsula in Mexico. Down below, the apex predators of the late Cretaceous period went about their daily routines, completely unaware of the mountain-sized object about to breach the atmosphere. In a matter of seconds, a random intersection of orbits would end a millions of years' reign and trigger a violent planetary reset. The exact moment of collision released a staggering amount of energy, equivalent to billions of nuclear weapons detonating simultaneously. This map illustrates the immediate geographical scar. The Chicxulub crater carved out a massive blast radius measuring 180 kilometers in diameter across the Gulf of Mexico. Within minutes, the crust buckled. Powerful shockwaves radiated outward, and continent-shattering earthquakes shook the planet. Hours later, the oceans responded. The immense displacement of water generated towering tsunamis that violently swept across ancient coastlines, obliterating everything in their path. The kinetic energy transferred by the collision ensured the destruction rippled through every geological and atmospheric system on the planet, turning a localized strike into a global catastrophe. The force of the collision was so intense that it violently ejected billions of tons of pulverized rock, dust, and sulfur high into the upper atmosphere. That airborne debris formed a dense, suffocating shroud. It completely blocked sunlight from reaching the Earth's surface for months, maybe even years, causing global temperatures to plummet. This biological pyramid shows the immediate chain reaction. Without incoming solar energy, the wide base layer of plants shut down. From there, starvation crept upward. The sudden loss of vegetation starved heavy herbivores, and without them, apex predators rapidly ran out of food. Making basic survival nearly impossible, starving animals had to contend with rapidly spreading global wildfires and highly toxic acid rain. A select group of organisms managed to hold on through the dark: small mammals, birds, certain reptiles, and a few marine species. Their survival came down to biology and scale. Because they were small, they could hide underground to escape the elements, scavenge efficiently in the ruins, and sustain themselves on vastly fewer calories. With the heavy dinosaurs removed from the equation, the planet possessed a staggering ecological vacuum. There were suddenly massive empty habitats and food sources, with no one to claim them. The surviving mammals finally crept out from the shadows into this massive open ecosystem. Free from giant predators, they rapidly evolved, diversified, and spread across the planet's landscapes. That explosion of mammalian evolution carved the direct biological pathway leading to modern humans. Had that rock missed our planet by even a fraction of a degree, the dinosaurs would have continued their reign, and humanity as we know it would not exist. Earth's most devastating mass extinction was the exact biological prerequisite for our own existence.